Let's work on the problem 2.6.12. Find I sub 1, I sub 2, and VAB. So when you say VAB, A is the higher potential. So from the circuit, we know this is plus, this is minus. Now, first thing we want to do, we want to combine all the series resistors together. This is series, and this is series. And if we combine them together, the circuit looks like this. We have two pairs of the parallel components. So now let's combine these together, these two together. So when we combine the parallel together, we need to multiply numerator and then add denominator. So we have 12 times 4 over 16, 4 and 4, 4 and 3. Therefore, we have 3 ohm in this side. And then for this side, we have 6 and 6. Multiply numerator and add denominator. 36 over 12, which is 3. As we discussed in class, if we have two parallel resistors, their values are the same, then simply you have a half of resistor. That's the value of that. Now we have a 3, 3, 3. So we can combine them together. Then we have 6 at the top, 9 at the bottom. Now we can apply current division rule. We're going to call this as I downward. So use current division. ID equals opposite 6 over combine those two, and then total supplying current is 3. So 6 over 15 times 3, that is 6 over 5 M. This 6 over 5 M is going downward. That means in here we have a 6 over 5 amp going downward. Now we can find the voltage for 3, 3, and 3. Now we need to think about the polarity for the positive and negative of the voltage. Since the current going in that direction, we're gonna have voltage here as a V source. So this is the current source given. That's the total source current gonna go around the circuit. Since this is the source current and going upward, always current going from higher potential to lower potential. So based on this current, we can decide this V of S. Now, when we do KVL in this loop, we have a minus Vs, and then we have to have a plus, minus, plus, minus, plus, minus. So that when you do the KVL, minus Vs plus the first voltage plus second voltage plus third voltage, and then that equals to 0. And since the current going through the 3 ohm resistor is 6 over 5, the voltage is going to be 18 over 5 and 18 over 5 here and 18 over 5 here. So when we do KVL, the Vs is gonna be 18 over 5, 18 over 5, 18 over 5. 6 over 5 is going into this node, and 6 over 5 is going to split into 2, 6 and 6, because 3, this 3 is the combination of this 6. So 6 over 5 should be split into here and here. So this is 6 over 10. 1 over 2 times 6 over 5. And this is 6 over 10. So when we add, it's going to be 12 over 10, which is 6 over 5. That 3 over 5 is going to come here, and 3 over 5 is going to come here, and then we're going to have 6 over 5 M going through that. And this 6 over 5 is going to split into 2. So this, we're going to call it I left, because this 6 over 5 amps going into this node is going to split into this 2 based on this resistor value. So I sub L equals opposite 4 over sum of those two, 4 plus 12 times total 6 over 5. Then that is 4 over 16 times 6 over 5, 3. This is 8, 4, 1, 2. This is 3 over 10 amp. What do we need to find? We need to find I sub 1. Where is I sub 1? It's right there. So actually I sub 1 equals to opposite direction of I sub L. Therefore, I sub 1 is negative 3 over 10 amp. Now we need to find the VAB. So let's redraw this circuit in here. Negative 18 over 5 volts plus negative 18 over 5 volts plus, and here is node B and here is node A and plus VAB. So when we do KVL in here, then plus VAB plus 18 over 5 plus 18 over 5 equals to 0. So VAB equals negative 36 over 5 volts.